Alright, folks, welcome back. We're having a night session, as you can tell up on the clock of the computer. It's a Wednesday, October the 19th, 8:54. In tonight's session, we're going to go over how to name metallic compounds. Another name of another, I guess you could say, phrase that they usually refer to these are stock elements, stock compounds. Let me go ahead and try to explain to you what metallic compounds are, or at least what I call metallic compounds. Basically, metallic compounds are compounds that just contain metals. We often just look at those quite simply as anything that's a metal. And you got to remember, a lot of part of the periodic table, a lot of the elements are metals. But more specifically, what I like to tell my students are metallic compounds are things in the transition area of the periodic table, the transition elements. You can also refer to them as transition metals if you'd like, and the post ones. Now, they're the ones, the metallic compounds I like to call them. That way, my students are able to think specifically about this area of the periodic table. But the metallic compounds are basically the ones that are able to have Roman numerals. And I have on the back of this periodic table a list of the ones that have Roman numerals, or at least those that are kind of common, that I've seen a lot, and I've got them listed here. No, this is not a complete list, but it's a very good hint out at what's out there to the students. So, anyway, let's go ahead and yes, I know the list is incomplete, but it'll do. So anyway, I'll have someone to actually ask me to go over naming metallic compounds, stock notation. So I've got a video on that, but I'm going to try to do an updated version. Maybe this one will be a little bit better. Let's start simple. Usually the easiest way to write these metallic compounds is if you're given the name, it's kind of easy to figure it out. Okay, let me just type in the name up here so you can actually see what I'm talking about. The name is actually very easy. Let's say that we have iron I said iron, but anyway, iron 3, and this iron 3 will say oxide. Okay, let me increase the size of that in case any viewers may be having trouble seeing that. Okay, alright, iron 3. Okay, we see the name. It's displayed on the screen. It's kind of straightforward. This area, right in here. Oops, they turn off the text and actually use the brush. Let me grab the green real quick. This part right here, the iron 3 part, it goes together. That's your metal, and that's its charge, the Roman numeral 3 that you see there. The word oxide, well, that's your oxygen. Now, one thing that I need to stress to everyone is your metals kind of played hide and seek, or they're kind of mischievous. They're kind of lying to you sometimes, and you cannot always trust them. But when you're given the name like this, iron 3 oxide, they can't hide the truth. You know the truth. You know their true charge. So let's try to write the formula on this one. Okay, it says it's iron 3. So let's see if we can get this iron 3 written correctly for a formula. I know that iron 3 is the ion Fe plus 3. Because they told me that. They said iron 3. Okay, now oxide, we know from naming tons of these that oxide is the element oxygen. Now, there's no way for us to know the charge of oxygen just by looking at the name oxide. There's not a way for us to know that. But let me show you something on the periodic table. On this periodic table, notice that oxygen is in column 16. Everything that's a nonmetal in column 16 has a charge as an ion of -2. Now, here's one thing I want you to remember. your non-metals are not going to lie to you about their charge. They're going to be what they're going to be. So like column 17 is -1 if it's a non-metal. Column 16 will be -2, -3, so on. Okay, if it's non-metals. That's the pattern. So let's go back to our example here, and we now know where iron got its charge from. It's -2. Now guys, I don't want you to start yelling at me. I'm just doing this. I don't want y'all to start yelling at me because I write my charges first, then my numbers. Because I know good and well that a lot of the books in the past and in today's market write iron 3 as Fe with a 3 with a plus, and they write oxygen O with a 2 with a minus. I'm very well aware of that. But you know what? It's hard enough for students to keep things straight in math, yet alone tying math in with science. And this is one of the things that has always irritated me, is that a lot of publishers and chemistry publishers do this to the students. You know, it's all we can do to get them to learn positive and negative numbers. Then all of a sudden, the chemists just want to start switching the signs just so they can be different. Well, that's scientists for you. They want to be a little different. Well, I'm going to be a little bit different too. I'm going to be one of those scientists, one of those chemists that does not put the charge behind the number because, quite frankly, it irritates me, so I just don't do it. Okay? Anyway, let's go ahead and try to get this formula. Sorry I ranted there, but it happens from time to time. Anyway, this 2 will go down here and become a small subscript behind the Fe. So that would give me Fe with a little bitty 2, okay, for a subscript. Now this oxygen will be written down, okay, and then behind the oxygen this 3 will plant itself, okay, so then we'll have a 3 there. And that is iron 3 oxide's formula. Now how nice is that? Very straightforward. We have no problem. We've got this down pat. Well, it's great, like I said, when you have the names right in front of you like this. But sometimes some students still get confused with even have the name right in front of them. Let's look at another one. We'll get this out of the way. Okay. Let's look at another name, and this one is going to be, let's say, I'm just going to make one up for us. Let's say it's, let's stick with iron again. Iron 3, I'll just pick something. Nitride. Okay, let me increase the size so all the viewers can see this. Okay, there, iron 3 nitride. Now let's try to name this thing. Now remember, Cantrell told you that this iron 3 is together and the nitride is together with itself, and we need to break them into ions so we can figure out the formula. Remember, stock notation uses Roman numerals. Okay. Now iron 3 would be basically writing Fe. I love the Roman numerals when they give them to you because you know the charge of that ion instantly. Okay, Fe plus 3. Now nitride is going to be N, but I don't know the charge of N because there's no way I can just look at this name and get the charge unless I have some things memorized or if I've got another tool. The other tool that I need is this periodic table. Now look at nitrogen. Nitrogen is in column 15. Everything in this column is -1. Everything in this column -2. Everything in this column -3. Okay, so we need to have -3 for our charge for nitrogen. See this? -1, -2, -3. Okay, so let's go ahead and put -3 on this. Now I've got -3 written. Now if you look, notice that this one has a 3 and this one has a -3. Okay, what I need to do now is figure out what I'm going to bring down. Now notice that this 3 and this 3 are pretty much identical. Well, they're basically multiples. Okay, I cannot have multiples with metals. I have to have the lowest number possible for my subscripts. Meaning if I wrote down this FE 3 N 3, I would be wrong, because these subscripts can be reduced. So my answer would have to be FE 1, which we don't write ones, then N. Okay, that would give me my formula for iron 3 nitride. Okay, now a lot of chemists, a lot of teachers, a lot of students will reduce them in the very beginning up here. They'll write their FE down. Sorry, I'm writing with a mouse. FE plus 3, or some teachers will tell them if they match, don't write them down at all. But you know, they'll say, hey, we need to reduce these, reduce this to a 1, reduce this to a 1, and bring them down then. I say reduce them whichever is easier for you. Pick a way and choose it, you know. So anyway, this is the issue that I wanted to address with iron. Okay, now on this, what you're going to need to do is just take your time, do lots of practice problems, and you'll get it. Now let's look at it when they just give you a formula. Okay, now let me get this out of the way. Now let's say that they gave you a formula of something like this. I'm giving us the formula, so let's just say we've got CO with a big O. That looks very strange, but we need to name this compound. Well, first of all, let's just name what we know. I know that CO is cobalt. Cobalt, C-O-B-A-L-T. That's cobalt. And I know that this big O is oxygen, which is oxide. Now, cobalt, if we look at our periodic table, cobalt is in column number 9, which is right here, number 27, the 27th element with 27 protons. Notice that it is a transition element, so it's got some charges that we need to look at. So let's look at cobalt on this. Notice that cobalt could be cobalt 2, cobalt 3. There could be cobalt 1, but I don't have it on here. But these are the two most common. Okay. Question is, which cobalt do we have? Well, this is where we have to actually think about what we have, because on that list I've got that it's possible to have cobalt 2 and cobalt 3. Now, which one do we really have? Well, we got to look back at the formula to see which one we have. We almost have to work backwards. Let's look. You've got CO with a big O. Now let's look. We cannot rely on this metal to tell us the truth. We know it could be plus 2 charge, or it could be plus 3 charge. We can't rely on it to tell us the truth. We do not know instantly which charge is intended to be used here. But we know that this nonmetal is never going to lie. So look at oxygen. Oxygen is in column 16. I said earlier that anything in column 17 is -1, that's nonmetal, and anything in column 16 that's nonmetal is -2 charge if it's an ion. Well, look what we've got. We've got the ion here. Okay, so this charge of oxygen as an ion is a -2. Now look down here. Do you see a 2 down here behind the cobalt in the original formula? I do not see it. It's not there. That means it must have been reduced at some point. It's showing here that it's a 1. Okay, just like it does up in the original formula up here. The only way that this 2 could get changed to a 1 is if it was reduced. So basically, every subscript that's down here has been reduced on the original formula. So that means that this one that you see here should actually really be a 2. Because if both were a +2 and a -2, they would totally reduce to 1s and be crossed down, or be written down as 2s, then reduced. Okay, so the name of this one is basically cobalt 2 oxide. Okay, I'll write it nice and neat if you want me to. Alright, cobalt. Ooh, I don't like that color. Cobalt 2. So C-O-B-A-L-T, cobalt 2. Almost looks like pi. Cobalt 2 oxide. Now, one last one and I'm done for tonight for an example. Okay? But there's our answer. Cobalt 2 oxide. Let's say we had something that was not as easy to tell. Okay? And I'm going to show you one that's like that. Get rid of this. One of the hardest ones to do is manganese. Manganese is just mind-blowing to a lot of people. Now, I see 4, so we can try manganese 4. Okay, that's one I want to pick. I probably shouldn't tell you, so let me pick another one. Which one do I want to pick? I'm going to go ahead and pick manganese. I like it. Sorry. Alright. Let's say I give us this formula to work out, okay? Let's say I give us Mn, you know that's manganese, manganese, and I give us an O and a 3 here. Okay, let's see if we can name this. Now we know that Mn is manganese. Okay, manganese. M-A-G, mag. Okay, manganese. The only thing is we do not know which Roman numeral we need here. We know we need a Roman numeral because manganese, if you look on the periodic table, manganese is in this area, Mn. As soon as I can find it, there it is. It's the 25th element. It's in column 7. It's a transition element. Okay. Now, manganese something, Roman numeral here, but oxide. We got to find that Roman numeral in order for us to be able to say we've named this correctly. Don't worry, we're almost done with this problem. Okay. Now, what's the charge of oxygen? All day long, every day, 24/7, every day of the week, every day in the year, you know, all that for eternity. What's the charge of oxygen as an ion? Well, it's in column 16. Remember? Well, it's a -2 charge. Okay. Well, let's look back at this. If it was a -2 charge, that's if oxygen was a -2 charge like it's supposed to be, it should be bringing a 2 down here as a subscript. Do you see a 2 here as a subscript? I don't see a 2 as a subscript. I see a 1, don't you? Somebody brought down a 1 here. Well, oxygen should have had a 2 up here. Well, that means that this 2 got reduced. So that must mean that this 3 that's here has been reduced as well. So it really wasn't even a 3 when it came down. What was it before it even came down? Well, it had to be a 6, right? Well, if you're not sure, what you can do is try to write down the one that you think it is, Mn, and we think it's supposed to be +6. And we know that oxygen is always -2. Just bring these down the way that you think they should be. And when you write it down, you get Mn with a 2, then you get your O, and then you get your 6. Now remember, with metals, you cannot have multiple subscripts, meaning they have to be reduced. Okay? So you could take half of these numbers because they're all multiple of 2. And then you get the MnO3. This is another way that you would know that you actually, let me make the O bigger. This is one way that you know you picked the correct Roman numeral. So this should be manganese 6. Now remember, 6 is V with an I. And I always put these bars above mine and below mine, still to this day. That's the way it was taught to me in elementary school, and it just stuck with me. I think you put bars with them. I don't know. It's been so long. But anyway, I still put bars on mine. So anyway, if you have any questions, just write me some comments, and I'll do my best to do another video if this wasn't clear enough. So y'all have a good night.